We're about to start. Till we'll start, that's the code for the Summit Cup or whatever. So you're welcome to punch it in and get some score for your Red Hat merchandise. So this talk will cover KVM virtualization and focus on the low-level bits and not about management, at least not high-level management such as Rev. And we're going to cover the roadmap for KVM and technology updates. So we're going to get RHEL 6.3 and further RHEL 7 updates. And don't commit to any specific release except the last release that got shipped last week. My name is Dor Laor. I run the virtualization team in the RHEL department, and I'm with the KVM project starting from day 0.
I'm Bhavna Sarathi. I'm the virtualization product manager in the platform business unit. And before we get started, I just wanted to mention that we do take feedback seriously, so please do take the time to provide us feedback regarding the session. All right, so let's get started. In this presentation, we want to prove to you that KVM is the best virtualization platform. There are a number of important points that we will be covering, like performance, security, the lower cost to customers, and the virtualization management. We won't be covering the management, but that's an important point here. In performance, we own the top 7 SpecWord scores. We'll talk more about that. Security, Red Hat pioneered security through SE Linux. The lower cost, our customers talk about lower costs to us all the time. And the virtualization management is the Rev management.
Now, let's check out the KVM architecture from 30,000 feet. I hope many of you are technical. So here it is. It's funny indeed, but the key takeaway of this slide, which is unreal a bit, is that KVM is a relatively small piece of code, highly sophisticated, highly optimized, but it's small and it leverages the Linux operating system as well as the CPU virtualization extension in the processor. So let's look at the more traditional architecture slide that we're normally using. So I won't cover too much about KVM. That is a model within the RHEL operating system, because I guess most of you are familiar with it. I'll just say shortly that KVM exploits out-of-the-box hardware enablement with the newest CPUs and the newest device drivers. We utilize the sophisticated memory management, the scalable scheduler of Linux, and the super flexible I/O stack, and the high-performing one. KVM is a model and as a process, and it talks to libvirt as a management interface, low-level one. And in the KVM team, we're trying to address the system as a whole, not just work on the KVM model specifically, but contribute to the other components of Linux. So we have some major contributions around memory management. And the nice thing is that a contribution that we make for memory management, for networking, is good not only for KVM, but good for standard processes. And there is the opposite flow of that we get advantages with cgroup, with InfiniBand, that I'm just hearing the performance team lead comes to me and get excited how KVM can do 20, 25 gigabits per second without just running it in the first time, without no intervention of hypervisor engineer. So we have a really terrific model. Now let's start seeing a glimpse of the feature set, high level, and later on we'll drill down towards them. Lately we're adding many features to KVM. So it starts with seal time. It's an ability to expose to the guest how much the host allocated CPU to other processes or other VMs. So the guest can be exposed to that and take scheduling decision based on that. It's a key advantage that KVM can't do, and unlike other hypervisors. We recently exposed virtual PMUs, that's performance monitoring. So you can run performance monitoring within the guest, exposing the physical CPU extension, and just like you do it on physical machines. We are adding guest agent to have out-of-the-box performance and specific features. We're going to talk about NUMA optimizations around memory, and we are adding live operations for changing block device while the VM is running. You can take snapshots of the image of the VM. You can change the block backend and move it while the VM running without any interruption or downtime.
We've also added new CPU model definitions into KVM to allow for new Intel and AMD processors to be enabled within the virtual CPU context in KVM. And this allows for the performance benefits that is associated with the new processors to be brought into KVM. And we support the Intel Sandy Bridge processor and then the AMD 6200 series, which is the Interlagos processor. Guest power management support. We have added a new feature to bring suspend resume capability into the KVM guest. We have S4, which is suspend to disk, and S3, which is suspend to RAM capabilities, which are native to the guest, which means it actually speeds up the suspend resume operations. vCPU hot plug. This is the dynamically allocating vCPU, the virtual CPU resources to the guest. Word.io Skazhi. So we have actually done extensive work to extend the KVM storage stack and added block.io improvements to improve scalability into KVM. USB 2.0, we've added the USB 2.0 emulation support into KVM, and this actually dramatically improves the desktop virtualization capability. We also have passed through a USB disk, USB device from the host into the guest. And we have some power management improvements associated with this feature as well. And lastly, physical to virtual. If you have a physical system, you want to convert that into a virtual machine and then run it on a KVM hypervisor. You can do that with the P2V utility, and this is something new that we have added to allow a user to convert that physical machine into virtual and then run it on a RHEL hypervisor or a REV hypervisor.
All these features that we're just talked about are added to the RHEL 6.3 release that was released last week. Plenty of new features brought from the cutting edge of upstream, sometimes even before it got accepted upstream. Our engineers really work hard in order to bring you the benefits of what is being developed right now and do extensive backports into RHEL, so we'll be able to provide these features really fast and accommodate any needs of our customer and match competition and plenty times outperform them.
So now let's focus on performance. In this section, we will not only talk about the performance benchmarks, we will also talk about a lot of performance features that we have either added to our product or are going to be adding to the product. So how many of you here have heard about SpecWord? Excellent. So I'm going to talk about it just briefly then. The important thing about SpecWord is the fact that it is not just another benchmarking that is there, just for marketing purposes. This is a real benchmark. It has been, people have taken trouble to develop it correctly. It is used for hypervisor benchmarking across the stack for the hypervisor, the guest OS, and the applications. And the way it works is there are 6 tiles, i.e. one tile, which is 6 VMs, and there are real workloads being run in each of those VMs. So this is a real industry standard benchmark for virtualization. So now let's look at the KVM virtualization results. This is a chart that looks at it from the CPU cores standpoint. The green bar refers to the VMware results. The red bar refers to the Red Hat generated results that our close partners, IBM and HP, have submitted to the spec word committee. And you see a lot of tall red bars here, which means our performance here is top notch, and we hold the top 7 results. So let's dig into this a little more and look at it from the socket standpoint. In the 2-socket category, we are actually 27% higher than the VMware results. In the 4-socket category, we are 22% above VMware. And in the 8-socket category, we don't have anything to compare against there because VMware has not submitted an 8-socket category. And in fact, VMware has actually stopped submitting results altogether.
They stopped?
Yeah.
Weren't they the ones that defined the benchmarks?
That's true. That's actually correct. But we haven't seen much coming from them in this area.
I wonder why.
Yeah. So.
Yeah, we have a question.
Yeah.
What version of VMware are you using for the benchmark?
You can check out the site and just Google this number.
The previous slide had the version down there.
Yeah, I can go back to that. And the versions, I believe, started with 4 initially because of the time frame. 5 was not out yet, and then later on it's vSphere 5.
The nice thing about it, our performance team did help with our partners to get these results, but HP and IBM are competing one against the other with submitting KVM results, while we stand in the side and just support them technically. But that's it. It's a huge gain from our partners and the OVA. Just we get that out of the box.
Yeah, absolutely.
Just last question, and we'll have reserved more questions at the end, but go ahead. It's it's a really complex setup to do. You need to be very skilled and experienced with it. So it takes like you run the topmost is about running hundreds of VMs, while each VM needs to match, and you need to measure a certain SLA. So you can't just run Zen and try to get to these numbers. You really need to submit stuff, and if Citrix will submit, we'll be happy to look and maybe offer some advice.
Okay, so we'll be talking about KVM scalability. I mean, we have awesome benchmarking results, so we want to actually talk about what leads to these great benchmarking results.
Thanks. So there are plenty of scalability achievements. This slide shows the maximum virtual CPUs per guest that we support. So we started with RHEL 5 with 16 virtual CPUs. We went up to RHEL 6 with 64 virtual CPUs, and now we released a release with 160 virtual CPU per a single guest. That's 5 times the VMware limit, and we actually benchmarked it. One of the things that was pretty hard for us is to find a benchmark that scales, because existing benchmarks do not scale on physical hardware. So, but KVM has like a minimum overhead, and that's why we managed to get to these numbers. So beyond vCPUs, there is memory. So how much RAM we give to the virtual machines. And I'm glad to say that with RAM, we also maintain leadership, and we get up to 2 terabytes of RAM for a single guest. That's, again, twice as much as VMware offer, not to mention the cost that you'll have to pay with their new model, but I'll leave that to product management to be all over VMware, but even technically, we're better. Beyond vCPUs and memory, there are plenty more stuff. Not everything is raw performance, and there are features, and we'd like to address that. So with RHEL 7, we're going to add PCI bridges, virtual PCI bridges. So that breaks the current limit of up to 32 PCI devices per guest. We got requests for more, so we provided more, or more of going to provide. This is upstream already, and we'll have it in RHEL 7. The new backend for block or front end 2 that was mentioned before scales up to thousands of devices per single guest. If you compare with VMware, VMware's limit is 60. It's only a fraction of what KVM can do.
No, I don't think that's right. I mean, are you sure? Have you double checked? I mean, it is VMware after all.
You know what? Let's be sure. I remember there is a page, configuration maximums. Here it is. Okay, so that's the official limits of VMware. Let's see. Hope it's. Let's try to enlarge it. Okay, so that's the maximum virtual CPU per guest. Yeah, we were right. It's only 32.
We did our homework.
And they do have the limitation of 1 terabyte. Also a swap terabyte. It's weird. And here are the maximum virtual Skazhi devices per guest. That's 60.
Okay, great. Thanks
okay,
for checking.
It's good that we verified that. And let's continue now. Oh. Hope you guys remember the architecture by now. Okay, there are plenty of other limits that we have breakthrough in, but I won't be able to cover it all now, and we can answer a question about it later on. But let's have one.
I have a question. VMware is recommending 1 CPU with 4 GB of RAM or 2 with 16, with 8 maximum. This is the best business practice. What is the difference between you and VMware having assigned workload? Let's say if I decide to have 16 CPUs for 2 CPUs with 8 core, what is the difference how you assign workload to the core with VMware?
I'm not sure. The workload comes from the guest. So we're.
For example, if I assign 16 CPUs on VMware, do they really use every core, or?
It's up to what your setup is and how many VMs you have and what's the hardware. So with any hypervisor, you can do overcommit or not of virtual CPUs or for memory. So it depends. KVM excel in overcommit for virtual CPUs and memory. So I'll love to talk about more, but it is a complex issue. So I invite you to unleash your limits today with KVM and move any physical installation to KVM. We support that. So with that, let's see some more.
Okay, so now let's focus on NUMA. Let's see what new features we have coming up, what we have already done, and what we've committed. So non-uniform memory access. You all must be very familiar with this picture. Basically, it is a 4-socket machine. These days, every machine has a NUMA architecture. The memory controller is on the socket, and you have local memory, hanging off. You have DIMMs hanging off of every socket. So now let's consider this scenario. We have 2 nodes, 2 sockets, and we have 2 CPU cores in each node. And we have 2 guests running, VM1 and VM2, and there are 2 threads running on each guest, vCPU1, vCPU2. And in this scenario, let's assume that the box is overloaded to start with when this assignment happens. And now the 2 threads are actually getting assigned to the same node, to node 0. It is not getting distributed the way it should, and everything is assigned on node 0, and node 1 is idle. So this is not optimal performance. This is not the way things should be running. The thing is, the Linux scheduler is actually, quite NUMA aware. But the issue happens when a system is overloaded. And when you have an overloaded system, the processes are assigned correctly initially, and then when it's overloaded, the processes are moved to the remote node. And when the system comes back to its current state, when it's no longer overcommitted and overloaded, then those processes are not moved back to the correct local nodes. That's the reason why you get situations like this when you install an operating system, you install and you don't get out-of-the-box performance. Now let's look at this scenario. This is our goal. We want to get to this point. Out-of-the-box performance, whether you're running, when you're running RHEL and you're running a hypervisor, we want to be able to achieve this right out of the box. And in this is the same scenario, but in this case, the threads are getting assigned correctly. They are getting assigned on the local node in node 0 and in node 1. We've done some improvements in NUMA optimization. In RHEL 6.3, we added a daemon, a user space daemon called NUMA-D. And NUMA-D is a user space tool, and what it does is it actually tracks some of the bigger processes and the memory access to those processes and ensures that they are assigned to the local node. And in addition to that, it actually works in conjunction with libvirt. And even before anything starts running, it makes sure that the large processes are assigned correctly, and the pre-placement of those processes are important. So we are happy to say that we have released this in the 6.3, RHEL 6.3 that just got released a week ago. And it is in tech preview. It's turned off by default, but it holds a lot of promise. And be sure to check that out. The next item that I want to cover is what we are doing in the kernel space moving forward to ensure out-of-the-box NUMA performance. There are 2 features that we are heavily working on and tracking upstream. One is AutoNUMA and the other is SCED-NUMA. So what is AutoNUMA? AutoNUMA is the automatic page migration for NUMA localization to ensure, using kernel heuristics to ensure that the process is correctly assigned so that the correct local memory is assigned to a process. And I have to say that we are very excited about this in the KVM community, to get this. But this is not a virtualization-only feature. Even physical systems will benefit from this, that it improves the scheduler greatly. And SCED-NUMA it's a completing solution. They are useful for different use cases. And SCED-NUMA actually has this notion of a home node. And home node, it looks at the CPU and memory in sort of a collected fashion to make its decisions.
Now, we reserved a special surprise for this summit, and actually it was a surprise for us. It turns out that I/O operation per second is a sexy area, and we have VMware and Microsoft trying to compete each other, so we decided, why not? Let's test KVM, how it does. So guess what? KVM managed to do 1 million.4 operations per second. I'll soon show you the VMware limits. the benchmark environment that IBM was helping us to put, and they did most of the testing, was using IBM X5 server with 7 8 gigabit HBA from QLogic, and it was a single host running these VMs. Now, here you can see the performance of KVM. So in the blue line, we have KVM results with PCI pass-through of these HBAs. So one guest can do up to 400,000, and it goes up and scales almost linearly to 4 guests with 1.4 million IOPS with 8K requests, both read and write. On the purple line, you can see what's going when you're using VirtualBlock, the emulated device. It's more of a use case that we expect our common clients to use, and it almost gets to the hardware level. The PCI performance are stock RHEL 6.2 KVM, and the VirtualBlock contains optimizations that we're now enhancing QEMU with, so it's not yet in RHEL. To compare with, the dotted line is the VMware results, way below. We can do even up to 1.6 million IOPS with smaller request size. We're not done with performance. There are plenty, although we're already pretty good with it, we'll continue to do further enhancements. So let's see what's coming. In terms of networking, we have 3 main models. On the left-hand side, we have the emulated devices. On the middle, the PowerVirt devices. That's the main use case. And on the right-hand side, we have device assignment. So we really want to optimize this case, which is already good and can easily saturate 10 gig networking, but let's optimize it even further. So the first major thing that we're adding is zero-copy networking. It means that when the guest sends or receives packets, the host won't be needing to copy it to the guest buffers, and guest buffers will be immediately transmitted to the NIC without any further copy. That reduces the CPU consumption needed for networking. The second one is virtual NIC multi-queues. So today, if you have a virtual net, it has a virtual NIC. It has only one receive queue and one transmit queue. But virtual machines today have plenty of cores of virtual CPUs. So we're enlarging in software the number of queues that are exposed to the guest, and the guest will be able to make use of this virtual NIC in parallel and send from multiple cores without blocking through a single CPU. That'll be another dramatic performance enhancement that we'll be able to deliver. It will work either if you have even a physical card without a multi-queue on the host. We have various live migration optimization. It's extremely important as the guest RAM grows more and more. The first 2 are pretty much implementation details, and I'll just say that it's more of a lockless implementation using sophisticated RCU mechanism, and the second one is dedicated thread for live migration. Let's focus more about the other 2 where I have slides per each. So this one is about adding caching and compression for live migration. When we live migrate a guest from a source to the destination, we need constantly to copy all of the guest RAM as guest pages from the source to the destination. If the guest that for the time being keeps on running on the host keep dirtying the pages on the source, we need to resend these pages constantly until migration will converge. And that's a lengthy operation and takes a lot of bandwidth. So we did an optimization to address it, because sometimes there's no need to send a full 4K byte page between the source and the destination. Sometimes maybe the guest may have wrote just a single byte there, and the hardware will let us know it in a 4K page granularity. So what we've done is using SAP code, actually. It's nice to have a community. What we've done is we're adding a cache. So above, we have the original page cached, and below here, we have the updated page. And we do data compression based on the diff between the two. And what will be sent is not a full 4K that were represented before by the red box, but just the tiny box in gray. So we achieve a dramatic reduction in the bandwidth needed for live migration, and also the conversion time is much more faster than before. On the destination side, we just do the matching decryption, no fancy stuff there. Similar and interesting optimization to gain more reduction of the data that passes between the two hosts is when you change the order of sending the RAM pages between the source and the destination. Before, we've done things like on the left-hand side, and after the optimization, things will be executed like on the right-hand side. Each triangle represents a single guest page. Now, we defined a notion of temperature or hot pages versus cold pages. Cold pages are on the green color. They normally are less written to by written to by the guest, and pages that are frequently written to are in the red. So if a page, let's say number 3, was sent to the destination, but afterwards the guest wrote to the same page, we need to send it again and again and again. And the idea in this optimization is to first send the cold pages on the green, and when we've done with it, only then send the hot pages. And thus we gain a big reduction of the traffic that goes between the source and the destination. It's a RHEL 7 stuff. I mentioned before the Virtual Skazhi Backend, and the reason we mention it again is because we're excited with it. It allows two main things, both performance and increase the feature set and the flexibility. Let's start with the latter. So it will allow you to use a pass-through of virtual HBA with NPIV. It allows Skazhi tape or Skazhi CD-ROM emulation and Skazhi CD-ROM burner, even like a pass-through of a CD-ROM burner. It is friendlier to a P2V process because it's just a Skazhi device. It allows thousands of Skazhi devices to be assigned to the guest. And in terms of performance, besides of being just a standard, really, really good virtual device already, it will allow in the future to incorporate very sophisticated features that comes from Skazhi, because this allows us to bypass the entire I/O stack on the host, and the Skazhi layer on the guest talks directly with the Skazhi target. So if your Skazhi target is a very sophisticated high-end storage array, you'll be able to make use of sophisticated features like Xcopy that copies the copy is done on the storage array without any I/O goes either to the guest or to the host. So it's really promising new layer for us. We even have more stuff. It doesn't end with it. We really gain a lot because we control both the guest and the host, unlike VMware, for instance. So we don't just have power virtualized devices. Our OS is power virtualized. So there are pretty unique optimizations that we can place. We're going to add PowerVirt spin locks, PowerVirt TLB flashes for optimized memory management, PowerVirt end of interrupts. It's more efficiency with interrupt handling without being too specific, and PowerVirt page fault. All are pretty excited, and it's possible to browse the material in the virus KVM forum uploads, but I won't be able to cover it now. And we touch a bit about PowerVirt timekeeping. Now, we're talking about Linux guests right now, but we're not abandoning our friend from Redmond, where we support their OS too. So what we're going to do with RHEL 7 is we're going to support Microsoft Power Virtualization. And I'm talking about the kernel, not the drivers. So Microsoft, like us, have pretty good Power Virtualization, and we're going to support this by KVM. So Windows OSs, the new ones that make use of Power Virtualization, will not only run optimized over Hyper-V, they run optimized in a pretty similar way over KVM. We're going to implement their interfaces. So I said before that not everything is performance, and it's very good to be high performance, but there are feature set, and sometimes it's more important than just performance. So we're trying to address this, so to migrate mission critical application towards KVM and provide a similar characteristic to such like the physical environment, and many times much better than the physical environment. So, for instance, we mentioned before vCPU hot plug. How many of you have hardware that supports physical CPU hot plug? Okay, we got 2, 3, 4 out of this big room. If you make use of RHEL 6.3 KVM, everybody will have vCPU hot plug. So these things are not common in physical hardware, and we bring them with virtualization. And it's really good to make a lot of time I hear that Windows IT managers tend to deploy virtualization, and Linux are not that excited. And most of the time it's because Linux is a pretty good operating system and allows you to do a lot of flexibility without virtualization, and that's true. But all of these new features, like live migration or block live migration, live snapshot, play more, bring you a lot of benefits beyond of what physical OS or physical hardware can do. We're breaking the limits of the physical world, and I really invite you to consider to move as much as low as possible to KVM. There are plenty more new things that will require a full day of sessions explaining virtual PCIe emulation, I/O throttling. We have USB 3 and thin provisioning improvements and cool niche things like shared memory between VMs using IV shared mem. It's a PCI device meant for that, but we won't be able to cover everything today, and you're welcome to either approach me afterwards, and I'll be able to refer you to material out there.
So now let's focus on security. How many of you in this room believe that security is important? Awesome. Everyone in this room, all of our customers, especially our federal sector, customers in the federal sector, believe that security is of utmost importance. And obviously we take this very seriously, and we started security in RHEL with SE Linux, and this was introduced way back in RHEL 4. And SE Linux continues to be sort of our driving force and our hallmark for our security strategy. And for KVM, we have built up on SE Linux and introduced SVirt. SVirt is a capability where security labels are assigned to individual guests and their resources. And this is done in the hypervisor. And we use mandatory access controls that SE Linux provides, and we have those. We ensure that the guest, if there's an attack on a guest, it is protected. The hypervisor is protected, and all the other guests are protected as well, because the hypervisor stores those security labels. In this picture, you see 3 VMs. And VM1 goes down because it is compromised, and VM2 and VM3 continues to run because it is protected by SVirt, and the resources and the storage, none of that is affected. And we like to look at security as an onion. there are many levels to it. We can't say we are done because we have SE Linux. We can't say we are done because we have SVirt. We continue to make forward progress on security. QEMU sandboxing. So we introduced SecComp, way back when. It was an upstream project. We did some work on it. Basically, SecComp is an application-level kernel syscall filtering. And we have taken that concept and applied it to QEMU. QEMU is our KVM user process, user space. And the QEMU is confined to a smaller footprint to allow only minimum set of syscalls. And what this does is it dramatically reduces the guest attack surface. It is worth mentioning that Google has uses this and has this support. They provided a lot of patches, and they have included this support in the Chrome browser. And this speaks to the power of the community and the community work that gets done and how everybody benefits from this feature. So another feature is, have you ever thought what happens to your VMs when they are retired? And this is another additional feature that we've added. We've added the wipe API to the scrub utility that is present on the physical hardware. We've extended that to bring the scrub utility that physical users have enjoyed and brought it to virtualization. And KVM, with this, we actually meet the PCI DSS, which is Payment Credit Card Industry Data Security Standards. And lastly, common criteria. It is near and dear to a lot of people that products have to be common criteria certified. In fact, in the federal sector, they will not buy any product that does not have this common criteria certification. At Red Hat, we spend, it takes a lot of effort, and it takes years and years sometimes to get an operating system common criteria certified. And I'm happy to say that RHEL 5 is common criteria certified, and RHEL 6 is in evaluation, and it is almost in the process of finishing this, and we should have it in the next few months. All right, so now every technology. Oh, go ahead.
How complex is SVirt to configure?
It should be fairly easy because what SVirt is, SVirt uses SE Linux. And libvirt automates the configuration of SE Linux and automatically labels all of the objects that every VM needs for its normal operation. So libvirt is there and dynamically create these labels for networking, all of the file descriptor, for block devices. So it just, out of the box, you get it, and the user is not really exposed to SVirt if you use libvirt, if you use Rev. Let's have one last question.
Okay, go ahead.
This is related to SVirt. Does VMware have anything similar to SVirt?
They do have security, I guess, but
nothing that
SVirt is our notion,
Yeah.
And they have their own security stuff. They have closed source, so
we don't know.
Yeah.
Any more? Okay, so let's move on to the KVM community and the ecosystem. We at Red Hat believe that every technology has to have a community surrounding it, and it makes that technology better. So let's look into it. So KVM is the hypervisor foundation for a number of products, and for a number of cloud products, for a number of hypervisor products, for a number of virtualization products. Our very own Red Hat Enterprise Virtualization, OpenStack, Overt is upstream, use KVM. And here's a really nice example that I'd like to give. IBM has, IBM Smart Cloud Enterprise, and they also have a research cloud that they use. And IBM is a huge, humongous organization. And they have, this is spread across 39 countries and thousands of nodes. And they were actually using Xen before they started to embrace KVM. And they actually migrated from Xen to KVM successfully without any downtime across 39 countries, a cloud that spans across 39 countries. So this really speaks to what KVM can do and how it can be useful in a cloud context. And just a handful of examples here, DreamWorks, eBay, NTT, Qualcomm. We have examples of Dutch Cloud using KVM. We have a number of examples, and we have thousands of customers using Rev, based on KVM. I don't think you can walk around in this conference without knowing what OVA is, and it's right on your badge. And OVA is Open Virtualization Alliance. We at Red Hat believe in open, open community. And this alliance is there to promote virtualization, data center, and cloud provider solutions, and basically to promote KVM, to promote the open virtualization, drive KVM adoption, foster a very good ecosystem, and promote customer successes. Just like you heard the last 10 years, RHEL has is there for our customers. Our mode of operation in KVM as well is working with hardware vendors, working with software vendors, working with an open community, open ecosystem to bring the best for our enterprise users.
Thanks. So we're wrapping up. So what we want you to remember out of this session, and I wish I had more time to cover features in more details. So you're welcome to find me afterwards, or even send our emails are at the end of the presentation. So the key takeaway is that KVM plus Linux, and I would say plus physical CPU virtualization extension, offer you better experience than the real thing. And the real thing for me is like physical hardware. So it's offer unmatched performance, unmatched scalability, huge feature set that doesn't exist on physical hardware. So just unleash your physical OSs and move to KVM. We put a lot of efforts to give all of these wide feature set, and also to enjoy for unique things that virtualization offers. So we've talked about feature, performance, open source. We couldn't have done it without a huge community. There's vibrating community. We have about 35 to 40 developers working just on KVM. But within Red Hat, the community itself of just the KVM and QEMU is about hundreds of people. And it doesn't stop here, because every tiny change to the Linux operating system as a guest, as a host, KVM immediately gets benefits from that. So, and it's all. It's C group, it's hardware enablement, every type of change out there we get benefit of. It's just we have the right model in terms of design and in terms of communication, collaboration, and with partners. So that's how we gain stuff. And now with Rev 3.0 and the next version of Rev, we have really good appealing management. It's really hard to manage KVM with low-level interface. It's really complex. And sometimes I even do not know how to run QEMU correctly, because it's a very huge beast and needs a lot of knowledge. So better go to a more sophisticated management, or be a partner and work a lot with us. And we have lots of experience with cloud deployment, and we especially promote cloud use cases. So the sandboxes that Bhavna showed is there to provide the best security to the cloud. So we're not just relying on imparting the common criteria achievement, but we're adding new mechanisms and new flexible things like Open vSwitch, for example. It's a terrific example for cloud and enterprise. And we're adding Glasser right now for KVM. So everything is there, will be integrated with KVM either beneath or below or above. So these are our emails, and if you have issues with KVM or feature requests, you're welcome to use them. There are references in terms of virtualization guides. We have 3 of them with a lot of knowledge. And there is the customer portal. And this link specifically talks about migration from ES6.5 or vSphere 5 to Rev. But there are plenty other examples, and there are examples how to set up the complex spec virt, for example, and plenty more. And with that, let's have a Q&A until the end of the session. Hi.
Oh, funny you should ask.
Pass-through of what? Sorry? CPU?
GPU.
Yes, there is work. There are even reports here and there that it was worked upstream, but we can't yet commit to a certain date. GPU pass-through is complex because each GPU is different, and even if you manage to do a specific GPU pass-through, the board and the BIOS settings may be different, and so we need to commit to a complete system.
Yeah. I mean, it's something that we do have in the roadmap in the future, but yeah.
Let's just see what's the time. I think we do have time. Okay, we have time.
Yeah, go ahead.
Yes, please. So was it a question? I didn't hear it all. They should be. We support it all, and we promote any use of KVM, no matter. And we have the reference architecture cover very good examples with SAP, or we have good performance with Oracle. So. No, some of them are in the motion. So now we shipped Fedora 17. So we do have stuff like soft page faults, and Virtual Skazhi is already in Rails 6.3 as a tech preview and in Fedora. But some other features are in the making. And with virtualization, we're trying to be very agile. So we're targeting to branch off Fedora 18 for Rails 7. But if there will be key features that won't be, the development won't end, we'll maybe keep on furthermore to get them into Rails 7. We've done the same with Rails 6. Okay, I think let's have one last question, and afterwards I'll be around.
I think we can take those.
Yeah.
This one, the first one from
Yeah, we didn't define the spec virt. VMware, IBM, and others define it, and we didn't do the testing, neither the VMware testing and even the KVM testing. We consulted a bit with IBM and HP, but that's it. Okay, thank you very much.
There's another question.
Thank you for using KVM.